Hello everyone. Let's continue on those examples on the 7.3 worksheets. I'm on example number 5 right now for this second video. So if a cos 2x is equal to minus 5 over 7, find the exact values of cos x. Okay, so now we have this questions on this one is already on the double angles for the cosine, okay? And since we're looking for the cos of x, so then I will bring out the double angles formula for using this one instead of the first one or the other one with the sine square theta, okay? The reason is because I'm looking for the cos x. So with this one, I can solve for this, okay? And all you have to do is to rearrange everything. So when you rearrange, you know that you have a cos 2x, which later I'm going to replace with this value minus 5 over 7, but plus the 1, and then everything divided by 2, then I will end it up with just a cos square x, okay? So basically, I bring in the double angles formula for the cosine, and I choose this one because my goal is to solve for the cos x. So this is the one that with the cos x on it, okay? And to get rid of the exponents too, all you have to do is you take the square roots of both sides. So you have this, and you will end it up with a cos x. Now, how is everything turned into? Well, then now I can start replacing some values there. Cos 2x is given as a minus 5 over 7. So minus 5 over 7 plus the 1 and divided by 2. Okay? And so this, you will end it up, okay, if you work it on the sine slowly, you will get into a plus and a minus of a 1 over root 7. But because we need to rationalize everything, so this becomes a plus and a minus of root 7 over 7. Okay, so this is going to be your final answer for the cos x. Okay, so I don't do any replacement until I can solve for the cos x when I bring everything over on one side, okay? And that is how you will be getting your answer here. Now, example number 6. You have an angle theta lies in quadrant 2. And given that the sine theta is equal to 7 over 25. So you always need to look at the information given. So since I know that this theta is happening in quadrant 2, so I quickly draw myself this reference triangle in quadrant 2. And knowing that the sine theta is equal to the opposite, 7 over the hypotenuse 25. So what is missing here is the x length, okay? Using the Pythagorean theorem, you can quickly calculate the length for the x in quadrant 2. So this one has to be equal to minus 24. Okay, plus and a minus, but in quadrant 2, this one has to be the minus. Okay, so in order to get the cos 2 theta, so all you have to do is bring out the formula first. And since I'm given the informations on the sine, then I think this time I'm going to choose this formula for the double angle for cosine. 1 minus 2 sine square theta. Because this is given. So when I'm trying to get this, 1 minus 2 times, okay, well, I know that sine theta is equal to 7 over 25. So if I put in this, that will give me the sine square theta. Okay, sine theta is equal to 7 over 25, but to the power of 2. That is the same as the sine squared theta here. Okay, so when you work this out quickly, and you will see you're getting, so this is a 49, this is going to be a 625. So that is the same as 1 minus the 98 over 625. So finally, you will get your final answer in 527 over 625. And I don't think I can further reduce this. So this will become your final answer for the example number 6A. Okay? Now, 6B. Find the exact values of a sine 2 theta. Okay? So, now, since I have, so again, I'm going to bring out the formula for double angle for sine first. And we all know that this is going to be a 2 sine theta cos theta. Okay? And based on the diagram that we have over here, we can easily replace sine theta is going to be given as a 7 over 25. But now cos theta in that quadrant is going to be equal to minus 24 over 25. Okay? And so when you work this out, okay, so it has to be a negative 336 over 625. And I think this cannot be reduced further. So this is going to be your final answer. Okay? Continue with example number 7. Example number 7, when you have an angle lies in between pi and 3 pi over 2. Okay, sorry. So this is my example number 7. So given the angle lies in this this range here, and between 180 and 270, that has to be quadrant 3. Okay, so an angle lies in quadrant 3, and the cos square theta is equal to 12 over 25. So cos square theta, I can quickly work out the math here. So when I solve for the cos theta, I will end it up with to be plus and a minus 2 root 3 over 5. Because this one is in quadrant 3, so your adjacent length has to be a minus 2 root 3. Okay, so adjacent over the hypotenuse, so this must be the 5. Okay, so the only length that is missing then has to be the y length. Okay, it's very important that we do everything ahead of time so that we can have everything we need when we are doing the question. So so let's also find out what the y length here is. So according to the Pythagorean theorem, you take the c squared minus, okay, and this is going to be the minus 2 root 3, okay, square. Okay, and you will work out that to be a plus and a minus of a root 13. So that means this one here, the y values in quadrant 3 is also negative. So this one has to be a negative root 13. Okay, so now we are ready to do our work here. For the cos 2 theta, again, we have to decide which formula that we're going to use. And in this case, since the cos square theta is given to us, okay, then I think I will likely to use this formula instead, okay, out of the 3. I try to avoid the one that with the cos and the sine so that I don't have to look for too many things. So if I stick with either the 2 cos square theta minus 1 or 1 minus 2 sine square theta, but because the question itself is already given this information, so I think it will be much easier if we choose this formula for the double angle. So I can take 2 times what is given is 12 over 25 and minus 1. Okay, and so that I can quickly work this out to be 24 over 25 minus 1. So your final answer will be a minus a 1 over 25. Okay, so this one will be a minus, sorry, here. Let me just make sure that I show this negative signs clearly. Okay, so it's a minus 1 over 25. Next one, sine 2 theta. So sine 2 theta, we have no choice. There's only one formula that is equal to 2 sine theta cos theta. So I can quickly work this out to be 2 times the sine. So based on the diagram, I know that I will have a minus a root 13 over the hypotenuse 5. And the cos theta is a minus 2 root 3 over the hypotenuse 5. Okay? So when you combine everything, so negative negative becomes a positive. So you have a 4 root 39 over 25. Okay, so this will be your part B. Okay, now the next question is a little bit challenged because now you have a cos of a 3 theta. And of course, in this case, then we have to use the compound angles formula to help us to start with. And then, okay, so this one, you can look at that as a cos of a theta plus 2 theta. Okay, so this is a compound, and because this is a compound, then I need to use the compound angles formula. Okay, so this is going to give me a cos A times a cos B. So this is a plus, then that means it's a minus, and then I have a sine A times the sine B. So now you have a combinations of the both now. Okay, for this question you have two different ways of doing it, but let's go with the most efficient way, because based on the part A and the B above, we already have informations on the cos 2 theta and the sine 2 theta. Okay, we already have an answer there. So basically, I don't really need to expand this further using the double angles formula because I already have the answer for those. Okay, so the rest basically is all you need to do is to get the cos theta. Okay, and I already know from the diagram my cos theta is equal to minus 2 root 3 over 5. Okay, but the cos double angle for cosine, cos 2 theta, is equal to minus a 1 over 25 from part A. Okay, and of course minus the sine theta based on the diagram, I should have a minus 13 over 5. And then the double angles for sine 2 theta from above, I already know that this is going to be equal to 4 root 39 over 25. Okay, so work this out slowly. So when you multiply the negative with the negative, you will end up with positive 2 root 3 over 125. And a negative with another negative give you a positive, and combine. When you multiply, you're going to get 4 root 507 over 125. Since I already have a common denominator, so I will be getting all of this combined. Okay, so this can go further, times this is going to be a 13, this is a root 3, okay, and everything over 125. So finally my answer is going to be a 54 root 3, because you have root 3 as a like term, so you can add them, all over 125. And I don't think this is reducible further, so this is going to be your final answer for part C. Okay, so do not try to plug in the formulas there for double angles for cosine or double angles for sine, because you already have the values for each of those from part A and part B. Okay, now for part D, okay, this one is a little bit tricky. This one here, we're looking for the cos of a half angle. And I don't have any information for the half angle, but I know that some of you might be thinking, oh, can I just make that into a double angles format, like a 2 times the 1 over 4 theta, because that will also give you. But the problem with this one is that I don't have any information on the quarter theta. If I'm solving for this one here, okay, instead of that, I will be using, since a cos theta is going to be equal to cos of a 2 half theta here. Okay, and so again, I will be solving for this. Really, it's based on the half theta. Okay, so this one really, and if I'm going to choose to expand this, I'm going to use the cos square half theta minus 1. Okay, I'm not going to use the sine formula, or the formula with the sine square theta on it, or the combined one, because then this way I can solve for that. Okay, let me just write this here. Okay, and so now I can rearrange everything. When I rearrange everything, so I'm going to bring over plus 1 and then divided by 2. So I will end it up with a cos square half theta. Okay, so when I continue, when I square both sides, so I will end it up with a plus and a minus square root of cos theta plus 1 over 2, then I will end it up with a cos half theta. Okay, a cos half theta is here when I square both sides. Okay, so it becomes over here. So I ended up with solving for cos half theta, and this is what I want. So what is the answer? It's going to be, well, cos theta, based on the diagram, I know that it's going to be equal to, so I still have a plus and a minus, but inside here, cos theta is equal to minus 2 root 3 over 5, and then I'm going to add 1, and then everything's divided by 2. Okay, so I still have a cos half theta here, and the result of that is going to be simplified into a plus and a minus. Okay, inside you will have a 5 minus a 2 root 3 over a common denominator of 10. Okay, so this is going to be your final answer because I cannot further reduce that anymore. Okay, and this one is a little bit trickier because what we're trying to solve for is a cos half theta. But instead of expand this into a cos 2 quarter theta, okay, so don't use that. Instead of that, I'm making this into a whole theta because a cos theta will also give me a cos 2 half theta. So by using this, I can further expand using the double Angus formula for cosine and just solving for cos half theta like that. All right?